When you picture Saturn, you probably imagine a calm, majestic yellow sphere. But beneath those rings is a turbulent, infrared storm world that has spent the last 4 decades defying the established laws of planetary physics. The issue comes down to angular momentum. When a massive gas giant is spinning through the frictionless vacuum of space, its rotation speed is essentially fixed. Because Saturn weighs 95 times more than Earth, slowing it down by even a few seconds would require a catastrophic planet-shattering impact. Yet that impossible speed change is exactly what our space probes recorded. In 1980, Voyager 1 measured Saturn's day length at exactly 10 hours, 39 minutes, and 24 seconds. Then, 24 years later, the Cassini spacecraft arrived and took the same measurement. But this time, the day was recorded as 10 hours, 45 minutes, and 45 seconds. A 6-minute slowdown on a world this massive is the rotational equivalent of hitting a brick wall. It shouldn't be physically possible, yet the data from our 2 best spacecraft were in direct contradiction. While astronomers were struggling with Saturn's spin, a second anomaly emerged. Silicon, the universe's 7th most abundant element, was completely missing from the planet's atmosphere. Gas giants act as massive cosmic vacuums, sweeping up the same primordial material that forms rocky planets. Their clouds should be packed with silicon, yet 40 years of probing found absolutely none. Both of these mysteries sat unsolved until the James Webb Space Telescope pointed its mirrors at a completely unrelated target 50 light-years away. Webb was studying a lonely, ancient brown dwarf. The chemical barcode recorded from that distant misfit ended up providing the data that dismantled both of Saturn's impossible mysteries at the exact same time. To solve the spin paradox, researchers used Webb to map the trihydrogen cation at Saturn's poles. This ion forms in high-energy environments, allowing Webb to use it as a precise atmospheric thermometer. This map reveals Saturn's auroras are massive heat engines. They create lopsided hotspots, driving 500 km/h winds. These winds physically drag charged ions across magnetic field lines, acting as a dynamo. This generates electric currents that pull Saturn's main magnetic field out of alignment. Saturn never actually changed its spin speed. Instead, its auroral winds were dragging its magnetic lighthouse beam around, creating a drifting heartbeat that fooled our probes for decades. This massive electrical dynamo reaches into Saturn's B-ring. In 1980, Voyager photographed dark, ghostly radio lines cutting across the ice, known as spokes. These spokes defy orbital mechanics. Because individual ice particles orbit at different speeds depending on their distance from the planet, any straight radial structure should be sheared apart within a single orbit. Webb's data shows that the same 500 km/h polar winds are connected to the rings via magnetic field lines. This circuit hits the fine ice dust with an intense static charge. This static charge causes the dust to levitate above the ring plane, creating the dark, ghostly shapes Voyager saw. The fake planetary spin and these radial spokes are actually 2 parts of the same interconnected electrical machine. While solving the spin paradox, Webb also looked 50 light-years away at an ancient failed star nicknamed the Accident. Inside this ancient brown dwarf, Webb detected silane, a volatile compound of silicon and hydrogen seen for the first time in space. But on modern planets like Jupiter and Saturn, oxygen is abundant. Silicon powerfully bonds with oxygen, forming heavy silicon dioxide, essentially quartz sand. That is why the silicon seemed to be missing. It isn't gone, it simply bonded into heavy sand grains and sank far beneath the visible cloud decks into a permanent geological prison. This discovery reveals the extreme environment inside Saturn, where the normal rules of rock and solid matter break down under millions of atmospheres of pressure. Inside these worlds, rock behaves like water. It melts, evaporates into the hydrogen sky, and falls back down as a continuous rainstorm of molten quartz. This silicate rain machine is a purification system. Over billions of years, it slowly strips heavy metals from the atmosphere and packs them deep into the planet's core. It took an unexpected look at a lonely misfit 50 light-years away to finally understand the mechanics of our closest planetary neighbors. Do you think we will ever build a probe capable of surviving a descent into Saturn's molten quartz rain? Let us know in the comments and hit the like and subscribe buttons to explore more of these cosmic riddles with us. Science is rarely a straight line, and sometimes the answers we need are waiting in the light of a distant misfit we found by chance.